Hi, today we're looking at section 5-5, the midpoint and distance formulas. So take out something to take notes on. Pause the video at any time to write your notes and complete the check it out problems on the worksheets. We have two learning targets today. The first one is I can apply the formula for midpoint, and the second one is I can use a distance formula to find the distance between 2 points. So midpoint, definition of midpoint is a line segment is a point that divides a segment into two congruent or equal segments. It's a midpoint. So it's halfway between the two endpoints. To find it, our midpoint formula states midpoint of line M, the midpoint M of segment AB with endpoints at A and B is going to be halfway between. So the distance from here is halfway, is equal to the distance from M to B. To find it, we take the average of the x-coordinates, so we add two x-coordinates together and divide by 2, and we take the two y-coordinates together and divide by 2. So again, it's written as an ordered pair with x, y. And so it's very important to write it as an ordered pair because it is, again, a point. So we want to find the coordinates of the midpoint of segment GH with endpoints. G is at -4, 3. So G is here, and H is at 6, -2. Okay, so to find our midpoint, start with the midpoint formula, plugged in our x-coordinates, add those together, divide by 2 to get 2/1, which simplifies to 1, and then we added our y-coordinates. 3 plus a -2 gives us 1 on top, which gives us 1/2. So our midpoint is going to be at the point 1 and 1/2. So our midpoint of that segment, GH, is about there. And you won't have to graph, but sometimes it gives you a nice visual. Here's your check it out to find the midpoint of segment EF. Now we're going to want to find the coordinates of an endpoint given the two midpoints. Okay, so plot the points. N is here, and N is one of the endpoints, and P is our midpoint. And we're asked to find Q, which is going to be our other endpoint. So we start with our midpoint formula. Midpoint equals the average of our x-coordinates plus the average of the y-coordinates. So our midpoint, we're told, is P is -1, 3 is our point. We're given one x-coordinate and one y, so we substitute those in, leaving us to solve for our x and our other y-coordinate. Let's break these into two equations, one for x and one for y. So -1 equals -5 plus x over 2, taking the first half to the x. It's our x and x. Solving for x, we get x equals 3. Breaking the second one in, this is our y term here. And we're solving for this, we're taking this as our second one. So we get 3 equals 4 plus y over 2. Solving for y, we get y equals 2. So our endpoint is at the point 3, 2. So if we were to connect all these lines, or all the dots there, we're going to have from N through P to Q. And so this is our Q, our other endpoint, has a coordinates 3 and 2. So you can look at this, and also you can see the distance. How much did the y change? It went by 4, so add 4 to -1. Our y went down by 1, so we have to go down by 1 again. So you could also do that. Look at the difference between the x and the y's. Now it's your turn. Now let's move on to distance formula. The distance formula, think of Pythagorean theorem. If you remember that, distance formula is distance equals the square root of difference of the x-coordinates squared plus the difference of the y-coordinates squared. Again, remember this is the difference. Midpoint addition, this is subtraction of the coordinates. So the steps are find the difference between the x values, find the difference between the y values, square the two differences, add them together, and then take the square root. And this is because this is like Pythagorean theorem where c squared equals a squared plus b squared. C is our hypotenuse, which you could see here, which would be distance we're trying to find between P and Q. So the square root both sides, we're going to get C is going to equal the square root of A squared plus B squared, which is the difference of the x coordinates plus the difference of our y coordinates squared. But you can just remember the distance formula. So we want to use the distance formula to find the distance to the nearest hundredth from points A to point B. So again, the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Substituting our values in, I used this as our x2, y2, x1, y1. It doesn't matter which ordered pair you pick first, just be consistent. So substituting the numbers in. Watch your signs, double negative, so we're adding. We get 36, 6 squared is 36, 5 squared is 25, add those together. Square root of 61. It asks for the nearest hundredth, so our distance is going to be about 7.81. Now you have a check it out to do, bring any questions to class. Now let's look at this one. Each unit on the map represents 100 meters. To the nearest tenth of a meter, how far is it from the roller coaster to the Ferris wheel? So using the distance formula again, substitute the values in using the ordered pair 2, 8 as our x sub 2, so 2 and 8 are our first x and y coordinates. And then we used 6 and 2, so 6 and 2 get substituted in for our x sub 1, y sub 1. 2 minus 6 is negative 4, square it's 16. 8 minus 2 is 6, square it's 36. Add them together, we get the square root of 52. Asks us to go to the nearest tenth of a meter, so it's 7.2 meters. And your check it out. So to summarize this, we looked at the midpoint formula, and it's the average of the x coordinates and the average of the y, and it's always written as an ordered pair. So make sure this is an ordered pair midpoint, and it's the x, comma, y, or is an ordered pair. And our distance formula is a distance between 2 points. So it's a difference of the x coordinates squared plus the difference of our y coordinates squared and the square root of all that. Good luck and bring any questions to class. Thanks.